Welcome back to the series on SystemVerilog. So in this session, we are going to discuss about tasks and functions in SystemVerilog. So let us see first the definition of tasks in SystemVerilog, and then we will compare this with the one present in Verilog. Okay. So coming to the tasks, what is the definition of task is in SystemVerilog, a task is a procedural block that allows for executing a series of statements. So tasks are particularly useful when you need to group code that perform operations involving multiple inputs, outputs, or when your code involves time-consuming operations such as delays, waiting for an event, etc. Tasks can be reused by calling them multiple times, helping to make your design more modular and easier to maintain. So, for example, if you want to execute a code, execute a line of statements for multiple times, instead of writing them multiple times, you can declare a task, and you can write all the statements inside this task, and you can call this task whenever or wherever you needed this statements to be executed. So you can call this task multiple times, right? So this is the basic use case of the task, and it is used for executing a series of statements, and they are useful when you need to group a group code that performs operations involving multiple inputs. So here tasks can contains inputs, outputs, or in-outputs or also like its arguments. So task can also contains inputs as arguments, outputs as arguments, and in-out as also arguments. And yeah, task can also contains time consuming statements like wait statements, delay statements inside it. Okay, task can contain time consuming statements inside it such as delays, waiting for an event, etc. And task can be reused by calling them multiple times, helping to make your design more modular and easier to maintain. So this is the task in SystemVerilog. And let us see the function in SystemVerilog also. So in SystemVerilog, a function is a subroutine. So it is a subroutine that encapsulates reusable code and retains a single value. So what a function retains, it retains a single value. So functions are primarily used to perform calculations or operations that don't require simulation time. Okay, and meaning they cannot contain any timing control such as delays or event triggers. So function cannot contain this event triggers or timing delays like the task, which can contain all the timing events or delays. Functions cannot contain any timing constraints like delays, events, etc. Okay, and here a function is used to encapsulate a function is a subroutine that encapsulates the reusable code and returns a single value. Here same like a task, instead of writing multiple statements for each time for your every case, what you can do is you can declare a function and write all the statements inside that function, and you can call that function multiple times wherever and whenever you need it. Okay, so this is the basic use case of functions and tasks in SystemVerilog. Now let us compare it with the Verilog. So in case of Verilog, if we declare a task or if we declare a function, and if we write any multiple statements inside this task, I'm talking about Verilog. If we want to write any multiple statements inside this task or multiple statements inside this function, in case of Verilog, you need to write begin end block. Okay, you need to write begin followed by end. So this is mandatory in case of tasks and functions of Verilog. Whereas coming to SystemVerilog, there is no need to write this begin end block for multiple statements. Okay, so in case of SystemVerilog, there is no need to write begin end for multiple statements in tasks and functions. Now, in case of Verilog, I'm talking about now Verilog. So in case of Verilog, functions can have only input as argument. Function arguments can have only of input types. So functions can have only input arguments. For example, function name, let's say ex, and it can only have input argument. That's it. Okay, whereas in case of SystemVerilog, we can have input argument, in-out argument, and output argument. So we can have all these three types of arguments in case of SystemVerilog. Okay, so this is the enhancement in SystemVerilog. And coming to one more enhancement, we have, so in Verilog, what happens is we cannot have void functions. In Verilog, we cannot have this void functions. What is this void function? Void function is a function which do not return any value. So in Verilog, function should return any value. Function should return some value. In case of Verilog, in Verilog doesn't support void functions. Whereas in case of SV, void functions are available. That is a function which is not returning any value. Void functions are acceptable in SystemVerilog. So this is a one more enhancement in SystemVerilog. Okay. Other rest of the conditions are same. Like functions cannot have any delay statements and functions cannot have any timing constraints. All that is same. Okay. So these are some of the enhancements in SystemVerilog compared to Verilog tasks and functions. Now let us discuss about static tasks and static function. So first let us discuss about static task and we will go to static functions. What is meant by static task? So a static task is in SystemVerilog is a task that does not maintain any state between invocations and shares its local variables across all the calls. Static tasks are instantiated once and their variables persist between calls. So changes made to variables in one invocation are visible in other invocations. What is this? So let us say in a module with some module name, and inside this we have written some logic and we have declared a task with some name and with some arguments and some statements inside this and end task, and within an initial beginning block I will call this task with this task name. Suppose this task name is ex. Okay, so I will call this task ex and I will pass some arguments, or I may not pass any arguments, right? Let's say we have some arguments inside it, int a, int b, like that. We have some arguments, or let's say we have some operation c is equal to a plus b. Okay, where a, b are input arguments and c is my output argument. Okay, so I'm passing a and b arguments. Okay, now I'm calling this task for the first time. What happens? I'm invoking this task. So for first invocation, a memory will be created for this task. Okay, so for first invocation, that is when I call this task for the first time, a memory will be created for this task, and all the members of this task will be stored inside this memory. Okay, is this clear? So this is case of static task. Okay, and if I call this static task for the second time by the name of the task, I will call it ex and I will pass the arguments, input and output arguments. I'm calling this for the second time, that is this is second invocation. I'm invoking the task for the second time. Then what happens? There will be no separate memory created for the second invocation. The memory which was created for the first invocation will be used by the second invocation also. That is the variables, that is the members which are already present. To that only the modifications will be done. Okay, so when we call the task for the second time, or when we make the second invocation, there will be no separate memory created separately for the second invocation. The memory which was created when we had called the task for the first time, or when we have made the first invocation, the memory which was created, that memory will be used by the second invocation call. Okay, so if when we have called this task, then what happens? When we call that second task for the when we call the task for the second time, then what happens? Then the modifications will be done on the same variables only, because the same memory is being used. So this is the static task. So by default, all the tasks in SystemVerilog are static. If you declare any task in module, then it will be by default in static. Okay. Now, coming to features of static task, coming to features, single instance. Only one instance of the task is created and shared across all the invocations. Okay. Any variable declared inside a static task, are shared between different calls. Shared local variables. Local variables are not reinitialized on shared invocation. If one call to the task modifies a variable, that modified value will be seen by subsequent calls. And default behavior. By default, tasks in SystemVerilog are static unless explicitly declared as automatic. So if you declare a task as automatic, then only it will work as automatic task. Otherwise it will work as a static task only. And lifetime, the variables in a static task persist for entire simulation, not just during the scope of a single call. So the variables which were used in this static task will be present during entire simulation. Okay. Yeah. So this is about static task. Now let's see an example for the static task. Memory. Okay. So let me declare a module. Let me zoom in. Module. Let's say static task example. So in this, I will declare a task called let's say increment, and with empty arguments, just I will increment some value. Let's declare a variable of int data type int I. Okay. Now in this task increment, I will increment it I is equal to I plus 1. Okay. Now let me call this task within an initial variable block. So before that, let me end this task, end task. Okay. Now within an initial begin, I will call this task. Let me call it increment, and let me call it again increment. Okay. So I'm calling this task 2 times. Okay. End module. Let me save this and let me simulate this. So before that, I should compile this. Compile, select. Yeah, simulate, start simulation, work, static task example. So I think I should write the display statement also. So I will write the display statement also. Wait a minute. Simulate in simulation. Yes. Dollar display, the value of I is percentage D after second increment, comma I. So I will copy this and paste it over here. The value of I is percentage D after first increment. Right? So let me save this and compile this. Yeah. Let me simulate this. Start simulation. Static task example. Yeah. Let me run this. Here we can see the value of I is 1 after first increment and the value of I is 2 after second increment. So what is happening here? So the value of I is incrementing 1 by 1. So coming to automatic task. What is this automatic task? So automatic task, each call to the task creates a new instance and local variables are reinitialized for the each invocation. This is more like a function call where variables have their own scope per call. For example, in case of static task, what is happening if we have called the static task for the first time? For say example, I'm calling the task for the first time. This is first invocation. I'm talking about static task. When we have called the static task, for the first time, then what happens? A memory will be created for this, all the members which are present inside this task, right? And when we have called this task for the second time, that is second invocation, then what happens? The same memory was used by the second invocation call also, right? So it was referring to the same memory which was created during the first invocation. But in the case of automatic task, what happens is when we have called the task for the first time, it is called first invocation. It will create a memory like this and all the members will be stored inside this memory. And when we have called this task for the second time, that is second invocation, then what happens? It will not refer to the memory which was created by the first task call. It will not refer to this memory. It will create its own local memory, and all the variables, all the members inside this task will be reinitialized. Okay, so this is the automatic task. So automatic task will not call the memory which was created during the first invocation call. It will have its own local copy. So every time you call a task, if you call the task for 10 times, for every single time a new memory, a local memory will be created, and all the variables will be initialized. Okay. Now let us see an example for better understanding. Now let us see an example for this automatic task. Let me create a module. Let me zoom in. Yeah. So module automatic underscore task underscore example. I will create a module, and inside this, I will create a task called, let's say, increment. Okay, and I will declare I will declare this task as of automatic type, task automatic increment. Yeah, and inside this I will create an integer I, and I will increment this integer I plus plus, or let's say I is equal to I plus 1. Also we can write I is equal to I plus 1, and I will end this. Let me display also because there are no input and output arguments. Dollar display the value of I is percentage d comma I, and in this task, and I will call this task using initial beginning block. So increment, I will call this for the first time, this is first invocation, and I will call this task again the second invocation, and this is third invocation, increment. Okay, so let's see what is the value of I in each invocation. Okay, now let me compile this. Yeah, compilation successful, and let me simulate this. Automatic task example, enter. And let me run this. Okay, I should initialize my I. So integer I is equal to 0. I should initialize, that's why I'm getting unknown value. I haven't initialized, that's why. Let me run it again. Simulate and simulation. Yes. And let me compile this first. Start simulation. Work. Automatic task. And let me run this. Yeah. So in the console we can see the value of I is 1. I'll call this task for the first time, first invocation, and the value of I is 1. This is for second invocation, and the value of I is 1. This is for third invocation. Like this, for every invocation we have called this task, we are getting the same value. Okay, so this is how the automatic tasks works. Now, one more thing I wanted to show you here. Let me end this simulation. You can observe here the variable I have declared inside the task itself. Okay, the variable I have declared inside the task itself. I have not declared outside the task. Let me declare this variable, one more variable outside the task, and let me show you the difference. So let us declare a variable int a, which is equal to 0, initialized variable. Okay, so I've taken integer variable, so that's why it's okay. Int a is equal to a plus 1. Okay, a is equal to a plus 1. Now let me also display the value of a every time when I call the task. Dollar display the value of a is percentage d comma a. Okay, now let me show you the difference. What happens when we declare a variable outside the task, and what happens when we declare a variable inside the task. Okay, yeah. Let me compile this. Compilation successful, and start simulation. Automatic task. Let me run this. Yeah, here we can see the value of I is 1 and E is 1. And when we have called the task for the second time, the value of I is 1 but E is 2. It is getting incremented. Okay. And the value of I is 1 but A is 3. It is get A value is incrementing but I value remains the same. Why? Because the variable A is declared outside this task. So by default, this variable will be of static in nature. Static in nature. So here we have declared the variable inside this automatic task, so it will become dynamic in nature. So that is the difference when we declare any variable outside the task and inside the task, automatic task. Okay, we think that we have used a automatic task, but we think that we have used a automatic task, and when we try to increment a static variable, and we expect that to behave dynamically, that like it will be shared across all the invocations, but it will not happen. Okay, because it will be in static in nature. That variable will be shared across all the task calls. Okay, all the invocations. I will show you with a diagrammatical explanation. So if we declared any variable outside the task, outside the automatic task, let's say in our case int a, okay, and we have written something task example, and we have incremented this task a is equal to a plus 1 and in this task. And when we have called this task for the first time, that is first invocation, then what happens? It will refer to the same variable which was created. Okay, so the memory will be created, and since it is a static variable, so since the task is automatic, I will show you that. The task is automatic. Okay, task automatic, so the variable will be created, a memory will be created for this variable, and for the second call, what happens? This is second invocation. So since the task is automatic but the variable is static, so it will go and refer to the variable which was created previously by the first invocation. So these two invocations will refer to the same variable itself. But in case of the variable which was declared inside this automatic task, int I, what happens for this? The two variables will have their own local copy of I. Okay, when we have called this task for the first time, it will create its own local copy of I, and it will store in own local memory. And when we have called this task for the second time, it will not go and refer to the previous variable. Okay, it will create its own local variable and it will store it in own local memory. So that's why we cannot see any modifications when we have called the second task. Okay, I hope this explanation is clear about the static task and static functions.